Good morning, dear students. Welcome to this session on pre-stressed concrete. We are discussing unit number 2. So, last session we have discussed some contents in unit 2, which is pre-stressing systems. We have taken up for the discussion. So, we have talked about uh, different methods for inducing pre-compression in concrete. Among them, the major concern is on the tension steel to use, right? So this is the technique. Tension steel in concrete is the technique that is widely popular and that we are going to discuss in detail. And we have also talked about tension devices, there are some mechanical devices and hydraulic devices, electrical, chemical, and among that, hydraulic devices are again very much popular, and you have the patented tensioning devices also. Now, by the study of the researchers, till date you have 60 plus such devices, pre-tensioning devices or post-tensioning devices which have got patented, right? And this session we'll talk about pre-tensioning systems. So we have taken up pre-tensioning systems. We'll talk about pre-tensioning systems in detail from this lecture onwards, and then we'll take up post-tensioning also. Okay. So in case of uh, pre-tensioning, what you have to understand, the tension is applied to the tendons before casting of the concrete. Okay, so pre-stressing is the what is required. Pre-stress is required. Okay, so if you have a concrete member, you need to stress that concrete before you use it. Okay, so you have to have some stress in it, which will help you to take care of the stresses which are coming onto the concrete when it is under service. Okay, so there are two such techniques to induce stress into the concrete. Those two techniques are, one is pre-tensioning, another one is post-tensioning. Okay, so pre-tensioning means what? Tension is applied to the tendons, means you have a tendon, so pull the tendon, apply tensile stress, apply tensile force that will create tensile stress in the tendon before casting of the concrete. So first you pull the tendon, then hold it, then you prepare the concrete. That is what is called pre-tensioning technique. Okay, right. In pre-tensioning system, the high strength steel tendons are pulled between two end abutments, and we will be discussing with a diagram also. You will be understanding better way what are those abutments. Okay, prior to casting of the concrete. Okay, the abutments are fixed at the ends of pre-stressing bed. So these are all the requirements in a pre-tensioning system. So you require a tendon, you require abutments, you require a pre-stressing bed. So these are all the requirements in case of pre-tensioning system. Once the concrete attains desired strength for pre-stressing, the tendons are cut loose from the abutments. So firstly, they are now pulled and tied or somehow held against the abutments. So once you prepare the concrete and see that the concrete have sufficient strength, then you cut the tendons. Okay, so that will try to regain its shape, whereas the concrete surrounding the tendon, the tendon is like this. Say the concrete is having a bond with the tendon, so tendon is trying to get to its original position, but the surrounding concrete will try to stop that. So that will try to compress the concrete. So that way the stress is induced into the concrete. Okay, it is purely from the bond between the concrete and steel. So the pre-stress is transferred to the concrete from the tendons due to the bond between the concrete and steel. Okay, so during the transfer of pre-stress, the member undergoes elastic shortening. If the tendons are located eccentrically, the member is likely to bend and deflect, which something like a camber means hogging. That I'll show you in the diagram also. So this explains the process of pre-tensioning operation. Okay. So let us see what are all stages of pre-tensioning operation. Like stage one, okay, anchoring of tendons against the end abutments. Okay, so have two abutments, and to one end you anchor the tendon, means hold the tendon by some means, maybe a bolt or something, by some device, anchoring device. Then the other end, place the jocks, the other end of the abutment, other end of the tendon, the other abutment, place the hydraulic jock. Okay, then apply tension to the tendons, operate the hydraulic jock, which will try to pull the tendon. Okay, once the required force is applied, stop operating the jock. Start casting the concrete. You have a bed already, the casting bed ready, where the tendon is available, pulled tendon is available. So prepare the concrete, let it set. Okay, get strength maybe 7 days, 28 days. Okay, right. So the required strength, okay, whatever is now you want to have the full pre-stress transfer, right? Then once the concrete is set, attains required strength, then cut the tendons. Okay, then what happens once you cut the tendons? Already you pulled the tendon, so it will try to go back to its original position, because steel is elastic, so it will try to come back. So during that coming back operation, it will try to compress the concrete. So apply compressive force, and that will try to induce compressive stress in the concrete. So that is what is called pre-stress. So during cutting of the tendons, the pre-stress is transferred to the concrete with elastic shortening and camber of the member. Camber is optional once if it is concentric tendon, means if the tendon is at the center of the member, then you don't find any camber. If the tendon is eccentric, then you will have a camber, right? So this diagram shows applying tension to the tendons. This is what I mean. As this is dotted line shown here, which means there is no concrete, it's just empty, there is a mold, that's all. This is what is called abutment. Okay, and this is what is the anchoring part, where we hold the tendon here. This is the tendon, steel tendon, high tensile steel. Then the other end of the abutment, the other abutment, there is a hydraulic jock that you see it here, which if you operate it, because of the hydraulic operation, it will try to pull the tendon. Okay, right. So this is what is pre-stressing bed that we call. So this is what I told you to have a diagram. So you must be able to draw these diagrams. Okay, remember, practice the diagrams part also, right, wherever it is necessary. Right, so this picture will show you end abutments. What are all end abutments? What is a steel tendon, where it will be, and what is a mold to prepare the concrete, and what is a pre-stressing bed, and the hydraulic jock position and anchor position, all that. Okay, then what next? Then the concrete has come. So pour the prepared concrete, you design the mix, and then according to the mix design, you prepare the concrete and pour it. Okay, so cast the concrete. Next step, you cut the tendon. You see it here? Tendon is cut here, here. Okay, so tendon is cut. So what happens once you cut the tendon? It will try to come back to its original position. As the tendon is eccentric, this is center position, this is eccentric, hence you can find that. So this camber is, the reason for this camber is that the tendon is eccentric. So this is the final position. The red colored diagram is the final position of the member. This black dotted line is the initial position of the member before tendon is cut. Okay, once the tendon is cut, then you see this red colored solid line diagram, and this dotted line shows the position of the tendon. Okay, after the concrete attains the pre-stress. So this is what is called transferring of pre-stress, transferring of the pre-stress from tendon to concrete. Okay, so this is in a simple diagrammatic representation what is pretensioning. Okay, what is going on in pretensioning. Okay, so just recalling, the pretensioning operation starts with a pre-stressing bed over which two abutments and a steel tendon, and one end anchored tendon, the other end there is a hydraulic jock. Okay, then applying pre-stress, applying tensioning the tendon, then preparing the concrete. Once the concrete is hardened, then you cut the tendon at the two ends. Okay, right, that will transfer the pre-stress to the concrete. Right, what are the advantages of pre-tensioning when compared to post-tensioning? So pre-tensioning is suitable for precast members produced in bulk. If you need some thousands, lakhs of such members, this is suitable. Pre-tensioning is suitable. Okay, if you want to prepare some number of members, like thousands, lakhs of such members. Okay, in pre-tensioning, large anchorage device is not present. So anchoring is very simple, maybe by means of a bolt or something. Okay, so anchoring device is very simple, whereas anchoring devices in post tensioning are no, they are very peculiar. They are patent, right? So there is a special need for anchorage device in post tensioning, whereas not in pre-tension. What are the disadvantages? Pre-stressing bed is required for the pre-tensioning operation. Whereas in case of post tensioning, you don't need such one because already concrete is cast, specimen is readily available. Then you start tensioning the no steel tendon, right? And there is a waiting period. Okay, so pre-stressing bed is one disadvantage. Waiting period in pre-stressing bed before the concrete attains sufficient strength. So at least a 7 day strength, if you have to attain, you need to wait for 7 days to pre-stressing bed to be vacated and ready for the next mold, right? So that waiting period is a problem with the pre-tension. And there should be good bond between the concrete and steel over the transmission length. Okay, if you provide the concrete member very lengthy member, then you will have more bond. If the member is short, less is the bond. And from the concrete reinforced design concrete chapter, then on what parameters the bond strength depends on. So bond strength, more the bond strength, the effective is the pre-stress. If the bond is strong between the steel and concrete, then almost 100% stress whatever you give to the steel, the same will be transferred to the concrete. Otherwise, if the bond is not good, then you lose the pre-stress. Okay, so pre-stressing bed is one disadvantage. Waiting period and good bond is a problem. Okay, so this is limited because bond strength is limited for the concrete, right? So these are the disadvantages. Advantages, when you want to make a number of members in bulk, maybe thousands and lakhs of them. Okay, and anchorage device is there is no need for special anchorage devices. Okay, simple anchorage device is sufficient. Okay, so these are the essential devices for pre-tension. Just now we have talked, but just once again listing them. A pre-stressing bed required, end abutments required, and a mold to prepare the concrete, and a jock is required for tensioning the steel, and anchoring device to hold the tendon at one end, and to the other end there is a jock to pull it up, and harping device whenever you need to position the tendon. Say you need tendon to be something like this, tendon position. So what you need is you need a device something like this to hold this tendon in this position. That is called harping device. Okay, so something like a hook, okay, to hold it. Okay, so that is something called harping device, which is optional. If you have a straight tendon, you don't need a harping device. If there are some kinks in the tendon, then you need a harping device. Okay, so these are the essential devices for pre-tensioning for the pre-stress to induce. Okay, right. We'll talk about much more in the next session. Right. Thank you.